Okay, so now in example 2, we're going to practice proving trig identities. And so for this first one, I'm saying to you what the method is going to be, what we're going to end up doing to get to the right-hand side. I'm not always going to do that, and so if you want to try to maybe cover up that first part here and just sort of scratch that out so you're not looking at it, that might be a good idea, but that's really just to kind of help you here to understand the different strategies that we're going to use. And so here in example A, we've actually already done this problem back in the 5.1 and 5.2 notes, but I want to do it now more formally as a proof and sort of talk through some of these strategies that we have. And so looking at tangent x plus cotangent x, I'm going to start there with the left-hand side and make it look like the right-hand side. Now, there's no fractions, so I'm not going to be able to split through the numerator or peel at the moment or find a common denominator. None of those are available to me right now because I don't have any fractions. There's nothing that can be factored out here, so that's not a possibility. A trig conjugate doesn't really make a lot of sense here because I don't see a 1 or a negative 1. And so really the last ditch effort here is to just change everything to be in terms of sine and cosine and hope that something develops from there. And so using a quotient identity for both of these terms, I know that tangent x is going to be sine x divided by cosine x, and cotangent x is going to be cosine x divided by sine of x. Now, using those quotient identities, I have now introduced two fractions. And so now all of my fraction methods or strategies are available to me. And I am adding two fractions here, which means that it's probably a good idea to think about finding a common denominator. And so if I find a common denominator, that's going to be cosine x times sine x. Now, I want to pause for just a second here and really explain this as well as I can. What I notice is looking at the target, which is secant x secant x times cosecant x, I see that this right here is going to get me to that target, because if I can move those to the numerator using a reciprocal identity, I'm done. And so I'm not going, listen to me very carefully, I'm not going to work on the right-hand side. I basically assume that the right-hand side is not there, other than using it to look at it occasionally to see how I should proceed and what strategies I should use. So don't work on both sides and then meet in the middle, so to speak. Work on one side and work it all the way through until you get the other side. But what I am trying to say is that you can look at this right-hand side and determine if you're on the right track. And so what I see is that based on what I have here in the bottom, if I were to use a reciprocal identity, I would end up with my target. And so that tells me that I'm on the right track. Now, if I continue with finding a common denominator, that means that I need to multiply this fraction by a sine x over a sine x. And so sine x times the sine x that's already there is going to give me sine squared of x. And then in the second fraction, I need to multiply by cosine x. And so multiplying by cosine x times the cosine x that's already there is going to give me cosine squared of x. Okay, now in the numerator, I am always making sure that I'm keeping track of, do I have an identity that I could use to make things simpler? And so what I notice is that there is an identity in that numerator that this sine squared x plus cosine squared x is equal to 1. And so I'm going to exchange that numerator for a 1 and then put here my same denominator, cosine x and sine x. And so now, because I have multiplication going on in the denominator, I can peel this by writing it as 1 over cosine x multiplied by 1 over sine x. And so now, using reciprocal identities, I'm going to be able to write this as my target, secant x times cosecant x. And so once again, what did we do? The first step was to rewrite everything in terms of sine and cosine. Then we found a common denominator here using a trig identity, a Pythagorean identity to be specific, we were able to rewrite the numerator as 1, and then we used the strategy of peeling to be able to get this to a format where we could use a reciprocal identity and end up at our target. Okay, here in example B, we're starting off with the fraction sine to the fourth of x minus cosine to the fourth of x divided by cosine x minus sine x. And so this is a fraction. It's not two separate fractions, so finding an LCD here won't really work. There really won't be anything to do to find an LCD, so that strategy is not really a good one. I'm not going to be able to peel because this is a minus sign in the denominator and not a plus or not multiplication like I would need it to be if I were going to peel. And I can't split this through the denominator because that can't be done. And so those fraction strategies don't really pay off here. Neither does trig conjugate. Everything is already in terms of sine and cosine, so that strategy is not really going to work, and I don't see any basic trig identities that I could use here to make this more simple. And so the only strategy that's left, the only one we didn't talk about yet, is the strategy of factoring. And so what I notice in the numerator is that the numerator is a difference of squares, because sine to the fourth of x is sine squared x squared, and cosine to the fourth of x is cosine squared x squared. And so I can rewrite the numerator as a difference of squares, where that will say sine squared x plus cosine squared x, and hopefully you're noticing something about that immediately, and then sine squared x minus cosine squared x, and that's going to be divided by cosine x minus sine x. Okay, now, in the numerator, I've got two parentheses now. The first one is a Pythagorean identity, and so sine squared x plus cosine squared x is going to reduce to 1 using a Pythagorean identity. The other parentheses is again a difference of squares, and so I'm going to again use a difference of squares and write that as sine x minus cosine x multiplied by sine x plus cosine x divided by cosine x minus sine x. Now, I'm very, very close to my target. Notice that my target is cosine x plus sine x with a negative. Well, I've got cosine x plus sine x here. It's just that somehow the rest of this is supposed to go away and be replaced by a negative sign. So let's see if we can work out why that is. Sine x minus cosine x and cosine x minus sine x are very similar. They're just different by a negative. And so what we're going to do here is just factor out a negative from that first parentheses. And so this is going to say negative of negative sine x plus cosine x multiplied by sine x plus cosine x, and then over cosine x minus sine x. And so now what I notice is that this parentheses and this denominator are exactly the same, and therefore they will cancel out, and we will be left with our right-hand side. Negative, and then I'm going to go ahead and rewrite that inside the parentheses so that it looks exactly like the right-hand side. Negative parentheses cosine x plus sine x. And so one more time, what we did from this step to this step is I took a negative out of this parentheses, and when I factor out a negative from it, it just changes the sign of those two terms. So that's why this became negative sine x, this became positive cosine x, and therefore this red and this red were able to cancel out since they're exactly the same.